Hello friends, welcome to this class. So we were discussing about alkaloids, right? So in this class, let us discuss about this papaverine, right? So what we are going to do is we do structure elucidation to find the structure of papaverine. What the scientists did, right? So I will go one by one. You just take down with me, right? So let us see. So for molecular weight determination and also melting point, they found that they means here scientist. So melting point of this papaverine, they found it to be 147 degrees Celsius, and also they found out the molecular formula, and it was C20H21NO4, right? So they found out this molecular formula. So the papaverine contains 20 number of carbon, 21 hydrogen, 1 nitrogen and 4 oxygen, right? So in structure elucidation, what they will do is they will see what kind of nitrogen it is, what kind of OMe3 other things they will find it, right? So that we shall see in this video, right? And also they found it that this papaverine contains isoquinoline alkaloid, they called, because you know quinoline structure, right? So this is quinoline and it is aromatic, right? It is aromatic. Isoquinoline means, see, nitrogen position is here. Instead of here, if I make the position of nitrogen that side, see, this way, here CH2 is there, right? So this is isoquinoline. So this is also aromatic, right? So they found out that this papaverine contains this ring, that is isoquinoline it contains. So they called this papaverine as isoquinoline alkaloid, right? So these are the few basics I told, right? Now let us see few more structure elucidation. So coming up to the structure elucidation, say they saw this one nitrogen is there with molecular formula, right? So what they did, they used to, now they are interested to find the nature of nitrogen, and we know that alkaloids are the natural occurring compounds which contain at least one nitrogen, and most of the times nitrogen will be basic only, but also there are few more alkaloids in which nitrogens are neutral and also acidic, but here but nitrogen will be the must in alkaloids, right? So they wanted to find out the nature of nitrogen, right? So what kind of nitrogen it is. So they took this papaverine, right? So papaverine, instead of writing papaverine, I will write P. They took this papaverine, to this they added methyl iodide, I hope, yeah. So they added only one equivalent of methyl iodide. So what they found, this papaverine containing nitrogen, it reacted with this methyl iodide, simple lesson 2. Nitrogen will be having lone pairs, it will attack and iodine will live, right? And it formed this CH3, instead of CH3 I will write methyl. And they found that this after this reaction, the compound which was formed was quaternary ammonium salt. So quaternary ammonium salt, what they concluded that, see, papaverine when reacted with this methyl iodide, they got this quaternary ammonium salt. It means this nitrogen, papaverine containing nitrogen is tertiary, right? Because see, if I have tertiary nitrogen, when I do reaction with methyl iodide, I will get positive charge here, and this methyl iodide I have added, right? So methyl will be here and iodine I minus will be there. So I will get quaternary ammonium salt, right? Quaternary means nitrogen attached to 4 bonds, so it gets positive charge, and there will be negative minus will be there. So positive mixture in the same compound means it is salt only, right? So they found out that the nitrogen present in papaverine is tertiary. So from this molecular formula, let me write it here, C20H21NO4. So within this they found out that this nitrogen is tertiary nitrogen, right? So they found out with this experiment. So they took the compound and methyl iodide and they got quaternary ammonium salt. So they found out the nature of nitrogen. So there are four number of oxygens, right? So what they did, they took the compound and they wanted to test the nature of oxygen. So what they did, they took this papaverine. So this is my papaverine, right? So they took this papaverine. So they added 4 equivalent of HI. 4 equivalent. They will measure it correctly and they will add 4 equivalent of HI. And they found out that since there are 4 oxygen, right? 4 oxygen. So they found out that it formed like this OH, 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 OH plus 4 molecules of methyl iodide, right? So from this experiment, what they did, what they got to know, so they concluded that papaverine has got OMe. Like this, there are 4 OMe, like OMe, like here, OMe, OMe, and OMe. Since it contains 4 molecules of OMe, it reacted with 4 equivalent of HI to form like this compound and 4 equivalent of methyl iodide, right? And they did this quantitative analysis to form whether they are getting 4 molecule of methyl iodide or not. So they got from estimation, they found that they are getting 4 equivalent of methyl iodide. So they concluded that this papaverine has got 4 molecule of OMe like this. Within the structure, it contains OMe 4 times, right? So they concluded that. So what they concluded? So these oxygens are present as 4 molecules like OMe. They are present and it is attached to some other carbon chain in the papaverine. Carbon ring I can call, or carbon chain, right? So this conclusion. And also when they analyzed this compound, this OH formed, right? So when they analyzed this, estimated this, they found out that all these OH were phenolic. So what does it mean? It means this OH is attached to something aromatic ring and OH is there, right? So it is phenolic. See, alcoholic we know, if this is there, this is simple alcohol, primary alcohol. If I have like this will be secondary alcohol, right? But here, if OH is attached to any aromatic ring, that is nothing but phenolic, right? So this is nothing but phenol. They found out that when they analyzed this, they found out that all the OH attached to papaverine were phenolic. It means all OH were bonded to ring-like structure. So what they concluded, and all these OH which are found after this reaction with hydrogen iodide HI, they found out that those oxygens which are forming OH were phenolic. Phenolic means there is any aromatic ring. We can call it as aromatic ring containing OH or AROH. Right. So these are the few conclusions they come up with. Right. So next what they did chemical degradation methods. Chemical degradation means they use some chemical compounds and they break this papaverine into pieces and they will get some other compounds. Analyzing those compounds, we can tell the structure of papaverine. Right. So let us see about them. Right. So what they did. So the next thing which they did was to find the nature of carbon chain. Carbon ring I can call, or chain, because they didn't know initially whether it is ring or chain. So they did this nature of carbon chain they wanted to find in papaverine. So what they did, they came up with degradation method. Degradation means they are going to break. See, if this is my papaverine, they are going to break it like this by using some chemicals, so that they will get these compounds like this. See, so these compounds they will get, right? After getting these compounds, they will analyze this. Its structure they will determine, After knowing all the structure, they can conclude that if I join all those things, I will get this papaverine, right? So this we call it as chemical degradation, because by using chemicals they are going to break the papaverine into pieces, right? So how they are going to do that chemical degradation, that we shall see. So what they did was, see, nicely you should understand it. So they took this papaverine, right? To this what they did, they added cold dilute KMnO4. So cold dilute KMnO4 is a mild oxidizing agent. So they got this thing, papaverinol, right? Papaverinol they got. Further what they did, to this papaverinol hot dilute KMnO4 they added. So it was mild oxidizing agent, now it becomes little strong oxidizing agent because condition, thermodynamic condition from cold to hot they are making. So from papaverinol they got this thing, papaveril, let me write it, what we will tell, papaverildin they got, right? So they found out that in this papaverildin it contains ketone group. Ketone means like this, C double bond O, ketone group. So what they concluded, so this is hot dilute KMnO4 means it is the oxidizing agent. So if I have secondary alcohol, because we know basic chemistry, secondary alcohol when it is oxidized we will get ketone. So they found out that this papaverildin is contain ketone, means here it is oxidized, so it contains here what? It contains here secondary alcohol, right? And here papaverine, when cold dilute KMnO4 we add, we will get this secondary alcohol, means here it should be contain any CH2 group, right? Like this. So what they concluded, here CH2 group was there, when they added this dilute KMnO4 they got like this, CH2, one H will be there, other H becomes OH, so they got secondary alcohol, right? Further when they added hot KMnO4 they got this ketone, like that they concluded. So what they concluded, there is one CH2 group like this which is bonded to some other side chain or the ring we can call. Further what they did, they didn't stop only here. Further what they did, to this only they added hot concentrated KMnO4 and started heating for very long time. They started heating it. So they found out that it produced a compound and its formula is C16H13NO7, right? So initially it was C20H21, right? See, from C16 means it has broken down and this compound was there, right? This compound when they analyzed it gave the test for ketone also. You know, I think how to determine ketone, 2,4-DNPH test will tell us whether it is ketone or aldehyde, right? Because it will form orange line. And also they got one more compound which consumed two equivalent of base, and so 2 equivalent of base, if a compound is consuming, it means what? It contains 2 equivalent of COH group, right? So it is dibasic we call, right? If acid is there, then it is dibasic because it is consuming 2 equivalent of base. So dibasic compound. So from this formula it gave the test for ketone also, and also it told that it contains 2 equivalent of COH, right? So these were the few reactions they came up with, right? So these are the few reactions. So what they got, it contains this CH2 group. The ultimate conclusion they can tell that because from this secondary alcohol, from that ketone they got and other things, right? You don't worry, just what I am telling you, go on writing with me. As the video continues you will get it what I wanted to tell you, right? So no need to worry, just follow me, right? I am nicely explaining it all, the basic chemistry, right? So once they did this, further they did this oxidation experiments. These were oxidation experiments. So cold came in for everything. But they took this same papaverine to this what they did. Now this time directly they added hot concentrated KMNO4 and they got these products. Let me write them nicely. Right. So these products they got OME and here COOH. Right. So this is the isoquinoline structure which contains some substitutions like COH group also there. So one compound they got this one, the other compound they got COH, OME and OME. They got this compound, and also along with that they got few more compounds OME, right, and here COOH and COOH, right. Along with that they got few more compounds like this COOH, right. So these are the four compounds they got, right. When they did this papaverine, they took direct concentrated hot KMNO4 they added and heated and they got these four products, right. And also same papaverine when treated with simple KOH base and warm condition they got the same four products, right. So further what they did, the scientists what they did is they started independently synthesize these compounds in lab, right. So if you want, this is veretric acid, the name of this is veretric acid. So names are there, no need to worry, right. So these compounds they got, but see, from hot concentrated KMNO4 they got four product, this warm KOH they got four product, but when they did with simple KOH in cold condition they got only two product. The products were, let me tell it so that you will get to know now the structure of that, right. So they got only two product, that one is these two products, right. OME here and OME here, and one more product was like this CS3 benzene ring, OCS3 and OCS3, right. So they got these two products. So from all these products what we can conclude, see here, let me conclude here. See, if I oxidize it I will get some aldehyde, right. So what they did, they all these compounds with that they could able to arrange them and they arranged it like this. See, OCS3, nitrogen here, right, and other things here CH2 and again benzene ring and here OCS3 and here OCS3, right, and here it is aromatic, right. See, now we had the molecular formula, it was like C20 na, C20 H21 NO4. See, they accounted for nitrogen which was tertiary, right. Nitrogen attached to two bonded carbon and one carbon here, so it is tertiary. And they accounted for OMe3 group, right. When it was reacted to 4 molecules of HI, it used to give 4 molecules of phenol and 4 molecules of methyl iodide. So methyl iodide means here, see, this line means methyl it is. I should not write it because you should know it all. So here line if I represent it is methyl. So we can simply write like this, O like this, or OCS3 or OMe. All are same only, right. So if I do reaction with the 4 molecules of HI, I will get 4 molecules of methyl iodide and phenol. See, phenol means aromatic ring containing OH. So aromatic ring containing OH. So they concluded this might be the structure, right. So these things, and also if you do oxidizing experiments, so this is CH2. If I use mild oxidizing agent, it converts it to OH, secondary alcohol. Further we can convert it to ketone, like that we can see, right? So these were the few points. So all these products, when they got, they arranged and they gave the structure of papaverine, and the exact structure of papaverine is this one, right? So you please note it down. This is how they got the, and also scientists, what they did, they independently synthesized these four products, right? How they synthesized, that also let me tell you. I have 9 more minutes, let me come fast. So this is my exact structure of papaverine, right? So please note it down. So this is the structure of papaverine, right? So let us see these four products which I had written here, those four products synthesis. So first what they do, this papaverine is having isoquinoline structure, right? Because this is isoquinoline, but initially scientists thought it might contain quinoline structure, right? So initially they thought this might be the structure, like that they thought, and they did the oxidation and they got this product, COOH, 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 and it is aromatic. One of the product within that four, one of the product was like that, because of which they thought it is quinoline structure. But later they didn't synthesize all the four product with this, so they switched it to isoquinoline structure, right? Next, so what they did to independently synthesize other things, so later they took this one, COOH containing OH group here, right? To this they did a H2SO4 and heated, electrophilic substitution, sulfonation, and see, since it is electron-withdrawing group, so it follows meta direction, favors, and this is electron relieving group, it with ortho it favors, and we will get here SO3H, right? And here OH is there, and here COOH. So this product they will get sulfonation. Further what they did, base OH minus they added. So ipso substitution reaction you have heard, I think. So in which this OS bond is weaker because of different in size, that bond can be easily broken, and here a nucleophile will attack. So this kind of reaction we call it as nucleophilic ipso substitution reaction. Nucleophilic ipso substitution reaction, and we got the product. So this was one of my product, and OH I wanted to replace with OMA, right? So I will take 2 equivalent of methyl iodide. If I add, I will get this product, COOH. Here also OMA I will get, and here also I will get OMA, right? So one of the compound they synthesized this. They synthesized this with quinoline, but with isoquinoline also we can synthesize it, right? And also they synthesized 2 more compounds, right? You just note it down, so that my bond is so small I can't fit everything here only, right? You just note it down along with me, right? So what they did, they took this compound. Now they took isoquinoline, see, right? So they took this isoquinoline, OCH3, and here something CH2 is there, and it is attached to some other thing, let us assume. So what they did oxidation, right? KMnO4, strong KMnO4 they added. They found out that, see, here this resonating structures, can I write like this also? Because they are resonating. So the bond will break like this. I can write these resonating canonical structures like this also, right? The bond will break here and bond will break here. So one of my compound will be like this. And also here CH2 group is there, oxidizing. So here also I will get COOH, and here COOH, because bond will break like this and like this, right? And here also we will get COOH, and this is aromatic, right, like this. So one of the product. Or there is possibility to break bonds like this also, right? If the bond breaks like that also, we will get these 2 products. Here COOH, here COOH, and here OMe, and here OMe, and it is aromatic ring, right? So these were the products, right? So with these products, all these products, they concluded that this papaverine contains like this structure. It contains a isoquinoline structure, and something here CY is there, something, right? And here OCH3 is there and OCH3, and it is aromatic. And also this CY, it is attached to some more ring which is to give this OCH3 here, OCH3. Because if I oxidize it, something if you say here, if you take CH3, if I oxidize it, you will get this product OCH3 benzene ring, and here COOH. If I take this CY as CH3. So further what they did, this CY and this CY, they combined it and they ended up getting this one, right? This is CY is nothing but CH2 here. So they combined all these things and they ended up getting the structure of papaverine like this. So now you should be able to write the structure of papaverine. So it is nothing but it contains isoquinoline structure like this, and here instead of CY it is CH2 here, and it is attached to one more benzene ring like this, from which they are concluded, and here OCH3 and it is aromatic, and here it is also aromatic, and here OCH3 and OCH3. Like this they concluded and they got the structure of papaverine, right? So in next class let us see how those reactions happened with the structure of papaverine. Till then, take care and have a great day.